Hello, this is the Code Critics. In this episode, we are going to look at the construction of lazy data processing pipelines using the NutsFlow library. If you haven't watched our videos on iterators and generators, I suggest you watch those first. Let us start with a very simple example to understand the common elements of data processing pipelines. Every pipeline needs a source that generates data. Here, the source generates the numbers from 0 to 9. Often, data streams are filtered. In this example pipeline, the next step is to filter for all numbers greater than 5. For more complex tasks that manipulate the number of elements that goes beyond filtering, a processor can be used. The processor here takes the first 3 elements from the data stream. To transform the elements of a data stream itself, functions are applied. Here, each element is multiplied by 2. Finally, every data pipeline needs a sink that collects or accumulates the elements of the stream, for instance, by summing them up. So, in this example, the source produces numbers from 0 to 9. We filter those numbers for numbers greater than 5 and take the first 3, which gives us 6, 7 and 8. After multiplying each element with 2 and summing all up, the result is 42. The most important aspect of data pipelines is that they are lazy, meaning data is generated and processed on demand. In Python, this can be achieved by using iterators and generators. Here the implementation of our example pipeline in plain Python. First, we create 2 helper functions, gt5 greater than 5 and mult2 multiplying by 2 for filtering and multiplication. Then we can build the pipeline. Range is a lazy sequence and the source that generates the numbers from 0 to 9. We use filter to extract the numbers greater than 5. iSlice is a function from Python's itertools library that allows us to take or slice the first 3 elements from the data stream. We then map the mult2 function on each of the elements and finally use sum to add all numbers up. While this works, the resulting code is difficult to read, largely due to the deeply nested structure of the code. NutsFlow is a library that largely provides syntactic sugar to make generator and iterator pipelines more readable. Here, the same pipeline, but now implemented using NutsFlow. The double greater sign indicates the chaining of iterators or generators and replaces the nesting by a linear sequence, which makes the code much more readable. Let's have a look at a more realistic example of a data pipeline, where we will implement our own source, sink, filter, processor, and map function. The pipeline we are going to implement will read some files, extract the lines from all those files, normalizes those lines by removing punctuation, filters for lines that contain given keywords, and finally writes those lines to a file. First, we import the NutsFlow library. NutsFlow uses decorators to specify the kind of data processing functionality to be used. In this case, NutSource annotates the function files as a source, which means it has to be the first element of a data pipeline and must return an iterator or generator. Here, files finds the paths of all files with the extension txt in the data folder, opens those files and yields the file path and the file object. Since files is a generator, nothing happens apart from creating a wrapper object when files is called. this one, and here we go, here's the wrapper object. We need a sink to actually make the pipeline to do anything. For instance, we can add collect to collect all the output files it's generating in a list. If we execute this, we get the paths of the two files and the corresponding file objects here and here. Let's go one step back and implement a NUT flow processor that extracts the lines from the files the file source generates. Here, the NUT processor decorator. The NUT's flow function lines takes the files generated as input. We iterate over the path and file objects the files generator produces. Since file objects are iterators over the lines of a file, the inner loop iterates over the lines of the file object f and yields the file path and the line. So the lines processor transforms a stream of files into a stream of lines. We can try this out and incrementally build the entire pipeline by connecting the files generator with the lines generator and adding a required sink. In this case, we use head to collect the first 3 lines from the files with their paths. Let's run this. So the output now is the file's path and the first 3 lines we get from the first file. Next, we want to remove some punctuation such as dots, question marks, or commata from the lines. We implement the following normalize function, and you can see it uses the NUT function decorator. It takes a line, which is a tuple containing the path and the text of the line, and unpacks it. We replace the punctuation characters in the text and return the file path and the new text in lowercase. We could try this new pipeline out and get the first 3 lines normalized and the file paths. Next, we implement a filter to extract all lines that contain keywords. The contains filter takes a line and a set of keywords. It unpacks the line to the file path and the line text. We then split the text into words, build a set, and if the intersection of the keywords and the text words is not empty, we keep the line. A NUT filter takes an element of the data stream, here a line, and returns a Boolean value, indicating if the element is kept or removed from the data stream. Note that all NUTs can have additional arguments, but the first argument is always what is fed into the NUT from the left side via the pipe operator. The 2 greater signs essentially. Finally, we implement a sink. There are several sinks such as collect, head or write CSV already available in NUT's flow, but as an example, here we implement our own that writes the data to a file. The write sink takes the lines and an output path. It opens a file for writing and then simply writes the text of the lines and the file path to the output file. The complete pipeline then looks like this. First, we define a set of keywords, here poly and complex. And then the pipeline starts by loading all the files, extracting all the lines from all the files, normalizing all lines, filtering for the lines that contain the keywords. Here we add additional printing to see what we actually write with the file, and then writing the lines that have been filtered to the file, to the output file. And if we run this, we get the expected output. So the file path first, and then the normalized line that contains the keyword, in this case poly, or in this case complex for the second line. To summarize, NutsFlow is a library to construct lazy data processing pipelines. It is essentially syntactic sugar to make chains of iterators and generators more readable. There are many predefined pipeline functions, so-called nuts, but it's easy to create your own custom nuts. NutsFlow makes the construction of lazy data processing pipelines easier and usually results in more modular, cleaner code. There is an add-on library NutsML that adds nuts specific for image processing and deep learning. You will find the links in the description. And that's it. Thank you for listening. You will find the links in the description, and please subscribe or like.